So acids and acid derivatives on reduction will get alcohols. And what are the common reducing agents? And I clearly listed out, just it is very important. So because presence of bifunctional group, we have to choose a suitable reducing agent. Okay, that is the reason we should practice this example. And next thing is here write down exception. So exception means just you write it. Yeah. How do you write it? Is yeah, no, just note write down here. Sodium borohydride, NaBH4, NaBH4, sodium borohydride, okay, now cannot reduce. Cannot reduce. Which functional group, Amma? Acid, COOH, COOH, and anhydride, RCO taken twice O, anhydride. Understood? And ester, RCO2R. These three cannot reduce. Cannot reduce. Cannot convert to alcohols. Changes to alcohols. So acids, anhydride and ester. A, E. Or any way you can remember. Acid, anhydride, ester. Acid, anhydride, ester. Or EAA. Remember like this. EAA. Ester, acid, anhydride, and acid directly. And what about other thing? The other thing is B2H6. You can write here B2H6. So B2H6 cannot reduce. Cannot reduce. Which thing? CHO group. No, it's not. It's not CHO. CHO can reduce. So one is acid chloride, COCl, and that's it. COCl is not reduced, except this. All acid and acid derivatives can reduce by this thing. Getting my point? And one note you can write. These are reducing agents. So even if you look at carbon-carbon double bond, carbon-carbon double bond, okay, na, is changes to carbon-carbon single bond by adding hydrogens over here. So here also there is a reducing agent. So here suitable reducing agents are what? Are reducing agents. Here the suitable reducing agents are, you can take B2H6. But B2H6 able to reduce carbon-carbon double bond and metal hydrogen, oblique hydrogen. So these two can reduce carbon-carbon double bond. Understood? Kashika, okay?
Yes, sir.
Yes. So copied?
Done, sir.
Yeah. So by seeing this reducing agents, let us come to know that sodium borohydride relatively weak reducing agent. Correct? Huh? So because in this case, three acid groups, acid derivative groups, okay, now will not reduce with sodium borohydride. So it is not, it is a weak reducing agent as compared to other things. Weak reducing agent. Clear? Yes. Let me give some questions. Are you copied this?
Yes, sir.
Yeah. Question, write an example. What type of question they supposed to ask in the entrance? So Actually, we need to prepare alcohol. Suppose they give cyclohexane with the carbonyl group one side, and other side is they keep ester CH2 C double bond O OCH3. So in this case, one side they took a lithium aluminum hydride. One side lithium aluminum, and other cases, other reaction, they took sodium borohydride, NaBH4. Yes, and other cases, you take here B2H6. Yes, just write the products. What are the products here? Yes, you go to the table and answer the question. So lithium aluminum hydride is a strong reducing agent, right? So wherever the groups are present, you can write this as, like a ketonic group turns into acid, alcohol, OH, and even ester part also turns into CH2OH, and that OCH3 also turns into methanol. So plus we get a CH3OH, right? Now here B2H6, it is able to reduce even ester group and carbonyl group. So same type of product we'll get here. So the product with B2H6 is, here it is OH, and it is CH2, CH2OH, and plus CH3OH. Because the enemy for B2H6 is only acid chloride. So, but acid chloride is not there. So NaBH4 cannot reduce ester. So it cannot reduce ester. Therefore, this part remains as it is, and only this part can undergo reduction. So you can write it is CH2, it is C double bond O, OCH3. Now this is a ketonic group turns into secondary alcoholic group. Clear? Understood, Amma?
Yes, sir.
Yes. Do one more example. First question and second question. Suppose if I give here an unsaturated aldehydes or ketones, say CH crotonaldehyde, CH, and it is C HO aldehyde group. So I'm taking here two different reducing agents. So uh, one is a lithium aluminum hydride. So one is a lithium aluminum hydride, LiAlH4, and the second one is metal H2. Metal H2 means what? Nickel hydrogen, like that. Yes. Can you write the product? Right? Different examples I'm giving here. So write down products here. Third one. So here it is double bond O. It is C double bond O, Cl. So again, I'm taking two different reducing agents. You should get a grip on this type of reactions. Some examples. So here I'm taking, say, lithium aluminum hydride, and it is B2H6. So as we discussed, B2H6, it cannot reduce only one acid derivative group, functional group, that is acid chloride. So on the basis of this, you could write the product as, yeah, please do it. So in this case, the product is CH3, it is CH2, CH2, it is CH2OH. Because, so one thing you have to notice that lithium aluminum hydride sometimes can reduce alpha beta unsaturated carbonyl group, but it should be pH. Therefore, you have to put your double bond as it is. Only one or two exceptional cases that it can reduce double bond. Other cases it's not possible. So it is CH double bond CH. CH2H. That means what? Double bond does not affect. But here, this is comfortable, freely reduces double bond as well as double bond. Suppose that means what? Double bond O can reduce, double bond C reduced. So the product is here CH3, it is CH2, CH2, it is CH2, it is OH. Right? So do remember, lithium aluminum hydride cannot reduce. Cannot reduce the pi bond between two identical atoms. Pi bond between two same atoms. Same atoms. Say that means carbon-carbon double bond, carbon-carbon double bond, and carbon-carbon triple bond. So it has some limitation. So even for lithium, even sodium boride cannot. Even you can add NaBH4 also. NaBH4 and lithium aluminum. But only one or two exceptions that lithium aluminum hydride can reduce. Where I'll tell you, just to copy and write the products here. What is the product, Amma? The product here, in this case, so it could be, it is OH and it is CH2OH. But here it is, so here it is OH and this remains COCl only, acid chloride. It cannot affect. Following? So by default, H plus is common all cases. Do remember like this. Done? What's the question right on here? Examples. Examples. First one. It is being like this. So it is double bond O. Yes. So the product is product radon, sodium borohydride, and in solvent is methanol. And the second one, so it could be ester, C double bond O, cyclic ester is double bond O, and yeah, one is sodium borohydride, NaBH4, and second one is lithium aluminum hydride. Wait. And the third example, it is methyl, lithium aluminum hydride. And so this is acid anhydride. LiAlH4. Okay now? Answers?
Done, sir.
Done? Yes. So next, hydroboration. Important reaction right now. Hydroboration. hydroboration oxidation. So what is hydroboration oxidation? Simply, hydroboration means addition of BH3 or diborane. So simple definition you can write here. Addition of BH3 to carbon-carbon double bond or carbon-carbon triple bond, right? Is called hydroboration. So during hydroboration, the product so far is called alkyl boranes. Listen carefully. So first part is hydroboration and second part is oxidation. So here product is, so the product is alkyl boranes. Alkyl borane. So let me write the reaction. Suppose unsymmetrical alkene I am taking directly CH3, CH, CH2 plus BH3. Actually, BH3 is a monomer of B2H6 because you have studied in 11th class structure of diborane, about dimerization, banana bond, etc. So what we get, Amma? Actually, if you take here 3 moles, so because it provides 3 hydrogens and one boron is connected to 3 alkyl groups, so we can write as it is alkyl triborane. You can write R, R means here, let us take CH3. Already I took CH3. Na? So it is CH3, CH2, CH2 taken 3 times, it is B. So what is the name? Trialkyl borane. Trialkyl borane. Simply, this unit we can represent as R3B. R3B. So this is a very important compound synthetically because from trialkyl borane we can prepare alcohols, we can prepare alkanes, we can prepare even carbonyl compounds, etc. Different compounds we can prepare from alkyl borane because this is very very important, right? So this part is alkyl borane. Then next, oxidation. Step B is what? Oxidation. Oxidation step. In the oxidation step, trialkyl boranes. Trialkyl borane on oxidation with continuation I am writing this side with hydrogen peroxide. H2O2 in the presence of what? NaOH base. Do remember this combination. Simply otherwise they use OH minus also. So forms is a continuation with H2O2 in the presence of NaOH form alcohol. Simply I can write CH3, CH2, CH2 taken 3 times. Okay, now B. So here 3 alkyl groups are there. Therefore H2O2, you can understand H2O2 as OH. So 3 OH groups attached to 3 alkyl groups and 3 OH groups attached to boron. So what is the product here? The product is CH3, CH2, CH2OH plus BOH taken 3 times. So this is boric acid, H3BO3, boric acid, like this. Understood? Actually, I'll give you the mechanism of reaction, everything, so that you will get more clarity on this. So 2 steps. That's what hydroboration, oxidation. Yeah. Copied?
Yes, sir.
So let's see the mechanism. How this mechanism important. Very simple mechanism only. Let us take carbon-carbon double bonded system as, see, if I take it as unsymmetrical, because with unsymmetrical only we can say whether compound is following Markovnikov or anti-Markovnikov, correct? So it is carbon. Here I am taking here CH3, here it is hydrogen. So in this case, B2H6 or BH3 simply, BH3. So the product formed here H2O2, H2O2 OH minus. So here carbon, carbon, it is CH3, CH3, this is hydrogen, this is CH3, and so the net it is nothing but it's completely the net addition is H2O. So I can write here H here and OH here, right? This is the product. So for this is a reaction. If I start the reaction in terms of mechanism, suppose here double bond is there, it is CH3, here CH3, here CH3, here H. Actually B2H6 you can write as like this one, or BH3 you can write as like this. So BH3 you can write as BH2 bond H. So first boron attacks, then one hydrogen attacks, and they will be attacked from same side. So orientation is matter here. I can do 2 types of orientations. One is BH2 and this is H. See it carefully. It is the first case 1. So this boron going to attach this carbon and this hydrogen attached to this carbon. And second case, and I can make it as hydrogen to this carbon, BH2 this carbon. So it is a second orientation B. So in this case, it is important step. This orientation is not possible. This is correct. Why the second orientation is not possible? Can you tell any particular reason for it? Because this BH2 group oriented towards more sterically hindered. This side is left side is C. Suppose let us put here C1 carbon. This is C2 carbon, right? So BH2 group, BH2 group, BH2 group always select the carbon. BH2 group always select the carbon having atom less hydrogens. Less hydrogens. Less hydrogens. That means you can say no, sorry. Excuse me. Here more hydrogens. What I'm telling. More hydrogens. More hydrogens means what? Less sterically hindrance. Less sterically hindrance. Got it? So the product is here. What is the product here? And both simultaneously, syn addition. Syn addition means what? So 2 groups attack from same side. Okay. So we get like this. So C, it is CH3. This is CH3. Carbon. CH3. Here hydrogen is there already. Now this is hydrogen. It is what? BH2. BH2. Do remember, suppose if you take here BD3, deuteroborane, then we should get here D. Do you understand, Amma? Any doubt is there here? No?
Understood, sir.
Yes. So here BH2 and this boron containing 2 more hydrogens. So this unit I can write as simply this entire unit I can write as R. This entire unit is R. So we can write as RBH2. Correct? So 2 more alkenes. 2 more alkenes will react. 2 more alkenes. So what do we get finally? R, B, R. This is R. Are you getting my point?
Yes, yes, sir.
Yes, because one more BH bond, 2 more BH bonds are there. Even they can reduce to 2 more alkenes for total 3 alkenes. Then next, it is a trialkyl boron we get. Trialkyl boron. Right. Copied?
Yes, sir. Done.
Yeah. The next, once the trialkyl boron is formed, and here I'll write like this R. So B, R, R. Simply, if you take here H2O2, actually H2O2 OH minus. This mechanism is somewhat different, but no need for you. That is simply you can understand in this way. Here, if you break this bond, this is side OH and OH given to one boron. Boron and this side cleavage, one OH to boron, one OH to alkyl group. And this side cleavage, one OH to boron, one OH to alkyl. So finally, what is the conclusion in this case? So these three BOH 3 taken times and we'll get here 3 moles of alcohol, 3 ROH plus where the boron is attached, that place OH is substituted. So BOH3 taken twice. Understood? So what is R? In the place of R, we can substitute what? CH3. It is CH3. This is H. And now this is CH2. It is OH. So the boron is attached to this carbonyl, terminal carbon. So I think one more carbon, one more methyl group is there. Here it is CH3. It is CH. Actually, what are the added groups here? The added groups are OH and this H. Right? So do remember what are the important points you have to notice for this reaction is syn addition. So no carbocation. And product is finally anti-Markovnikov product. Anti-Markovnikov's product. And next one is regio specific. Regio selective. That means where we have to put OH, that will be decided. And next, stereo specific. Stereo specific means syn addition or anti addition. Specific. Okay. These are the characteristics. I will give some examples. You can do examples. Yes. Compare the following reactions. If I give one thing, It is there here, double bond. So plus, otherwise I'm taking two conditions. So what are the conditions here? One is, right, B2H6, H2O2 and OH minus. And second one is B2D6, H2O2 and OH minus. Yes, do these reactions. And next, one more example. If I take a cyclopentane system, there is a double bond. It could be CH3. Yes, plus BH3, H2O2, OH minus. Write the products. Are doing them. Just to see the products. If you have any doubts, you can ask me. Understood?
Yes, sir. Understood.
Yes. Copied up?
Yes, sir.
Okay. Then you write some other applications of alkyl boron. Some applications. Applications of alkyl borons. Alkyl borons. So let's see. Here R3B, trialkyl boron. When you treat it with acetic acid or CH3COOH, and when you treat it with AgNO3, when you treat it with H2O2, OH minus. So the products are here. Simply we'll get RH. Alkane is the product. Here it is R bond R. Here also alkane is the product. Here already we discussed alcohol is the product. Yeah. See the reaction. So reaction is if you take R CH double bond CH2 plus H2O. So Hg OAC taken twice. NaBH4. So the product is same. RCH CH2. Now here it is OH. Here it is H. So it is follows Marconi rule. Let's see the mechanism. Afterwards, we'll write the characteristics. Look at the mechanism. First of all, you can write that mercury diacetate is taken twice. It will be dissociated as like this. So Hg OAC, it is plus ACO minus. One of the acetate ion, this acetate ion will come out. So Hg plus is formed. And do remember in the second step, the second step is that R CH double bond CH2 is there, plus I am writing this mercury ion. I can write as Hg, so OAC like this. So it is plus. So what happens here in this case, simultaneously two things happens. One is this pi bond will be shifted to polarized to mercury, and this mercury contain a lone pair of electron. That lone pair will be transferred to this adjacent carbon. So in this case, you will get a cyclic mercury ion intermediate. It is CH2. So first of all, this is a basic reaction. Unsymmetrical alkene I took. So unsymmetrical alkene is going to be, reacts with water in the presence of mercuric acetate followed by NaBH4. The product is formed and which follows simply Markovnikov rule. So OH is at choose the negative part of the reagent, that is OH minus, choose the carbon having less number of hydrogens of double bonded carbon system. So if you go through the mechanism, step one, what happens? This mercury acetate ion will be dissociated into what? Mercury ion plus acetate ion. Now this is an electrophile. So this is an electrophile. So electrophile. Now electrophile is reacts with nucleophile. This pi bond is nucleophile. In this case, two things happens. One is that pi bond shifted to electrophile, and that electrophile contain lone pair that will be gives back to the electrophilic carbon. So resulting what we get here, one cyclic mercury ion intermediate is formed. OAC, this is plus. Right? So this is an intermediate. Important. Listen carefully. Then step 3. Is it clear?
Yes, sir.
Any doubt is there here? Because mercury contain lone pair. This lone pair, if this pi bond shifted to here, this carbon gets negative charge. The negative charge, makes bond with the positive, that mercury ion, and the this carbon gets positive. That positive again takes electrons from mercury lone pair. So this three-membered ring is formed here. Three-membered ring is formed. Done? Fine. So next, in the next step, what happens? That three-membered ring RCH, it is CH. So it is mercury. It is plus charge. OAC is there, being like this. And this step is crucial. Suppose if I introduce here water, H2O. H2O choose the carbon having more positive character. More positive character where it is available among these two positions. The first position, it is first position, it is second position. So that more positive character, more electrophilic nature is here. Because the resulting carbon plus charge is stabilized by this inductive effect, R group. So that this is more electrophilic center. More electrophilic center. Electrophilic. Therefore, so water choose this carbon to attack. So what do we get here? Thereby this bond shifts here because already this has plus charge. So that the product is what? The product is here. The product is, you can write here R, it is CH, it is water is added. So OH, H, and this is CH2 here, Hg, no, OAC. Understood? Being like this. Now, here this oxygen carry plus charge. And next step, so minus H plus protonation, deprotonation takes place. So this product is R, CH, OH, TCH2, HgOS. So when now you treat it with the sodium borohydride, if it is sodium borohydride, and in this case, if you take sodium deuterohydride, NaBd4, so we get two type of products. So one product is what here? It is RCHOH, it is CH2. So here it is H, because this H is transferred from here. And if you take deuterium, that RCHOH, it is CH2, it is D, like this. So hope you understand. Now this D is comes from this deuterium replacement. So this bond readily undergo cleavage. This is the final product. So note down, it is nothing but electrophilic addition reaction, and follows Marconi curve rule. And no rearrangement, because here no carbocation, because cyclic mercurium ion does not allow formation of carbocation. So here no carbocation. So therefore no rearrangement. No rearrangement product. And yes, so of course these are the main characteristics. Got it? Any doubt is there here? Yes. Here H2O, H plus. Here I can say OMDM. Here I can say HBO, hydroboration oxidation. HBO stands for hydroboration oxidation, right? So write down A, B, and C. Just to give the structures of, this is your homework question. Structures of A, B, and C. By oxo process. So what is oxo process? It is also called carbonylation. Carbonylation process method, or hydroformylation. Hydroformylation process. So actually very simple it is. So what is the reaction? Alkene plus carbon monoxide plus hydrogen. So the catalyst is what? Cobalt catalyst. So the catalyst you can write as cobalt carbonyl hydride. Cobalt, it is hydrogen, and carbon monoxide taken 4 times. So this catalyst name is cobalt carbonyl hydride. And it is a complex mechanism. The mechanism is not required. Catalyst. Right. So simply the product obtained here, it is first aldehydes. CH3, CH2. Yeah. So simply, of course, I didn't give any structure, therefore simply write aldehydes. Aldehyde. So that aldehyde, further reduction. aldehyde further reaction with zinc copper couple H2. So we'll get alcohols. This is a basic reaction. So let me give one example. Suppose if I take here 2 moles of propene, CH3CH double bond CH2 plus 2 moles of carbon monoxide plus 2 moles of hydrogen. The product is here. Actually, how do you understand this? Simply also you can write here. In this case, we get 2 moles of formaldehyde. Just assume like this. It is not reaction so simple, but you assume like this to make you understand. I'm giving in this way. So do remember H and the other part is CHO. So H is attached to one carbon, CHO are attached to other carbon. Two possibilities we have. Therefore, we can write two different products. So in this case, I can write if H is attached to one carbon, the middle carbon. So I can write CH2 that is turns into CH2, and this is already CH2 is there. Now it is CH2. And other possibility reverse opposite. CH3, CH to this CH2 is attached, and this is already CH2. One more hydrogen attached. It is CH3. Right. So even this compound, further reduction with the zinc and copper couple. You can write here zinc copper H2 reduction process. We get the CHO turns into CH2H. So the product is CH3, CH2, CH2OH. And here also say H2. So CH3CH is CH2OH. Now it is CH3. Two different products are formed. Hope you understand. So if you have any doubt, ask me. So mechanism is not required, just to remember oxo process like this. So there are two methods I have given for preparation of methanol. One is from syngas, other one is from methane. Okay, and also you can add your destructive distillation. Destructive distillation of wood. Okay, gives methanol as one of the constant compound. Methanol as one of constant compound among different compounds. Right? So take down, note down fast. So C12H22O11, it is containing a disaccharide. This is a name is molasses. It gives the presence of enzyme invertase. So it forms 2 moles of what C6H12O6. Right? Now this is containing maltose C6H12O6, and which is undergo one more even maltose if you take this enzyme and maybe contain glucose. So this is treated with xymase. You will get here 2 moles of C2H5OH plus carbon dioxide. So this is ethanol. Okay, Nama? So these are the preparation methods of alcohols. So we discussed very clearly. Just note down the remaining topic will continue in the next class.